So in this video we're going to talk about, this is video number 7 on biostatistics. We're going to talk about number needed to harm and number needed to treat. So let's move right into it. So step 1 is understand what attributable risk is. If you do understand that, you can actually move on very smoothly into the calculation of these other two new terms. And actually we're missing a third term right here that we're gonna see it briefly. So okay, what is attributable risk in general? Attributable risk in general answers this question: how much does the factor of exposure or the exposure increase the incidence rate of a group? So attributable risk includes the word risk. So how much of this risk is attributed to the risk factor or the exposure? That is why the exposure will generate a higher incidence than the non-exposed, because if you're exposed to a risk factor, you're gonna get the outcome more often than not. That's why, or more often than not being exposed, that's why the subtraction goes this way: A over A plus B, which is the incidence in the exposed, minus C over C plus D, which is the incidence in the non-exposed. So attributable risk goes with risk factor, goes with which number needed to treat or harm. You decide upon this. Is it good? Is it bad? You tell me. Yeah, the answer is number needed to harm. Okay, that's why you have these sad faces all over, because exposure will make you sad. Smoking is a risk factor, and it's not gonna have a smiley face on there for sure. It's a bad thing, okay? So let's see the other case. Here is where we bring the other word into account, which is absolute risk reduction. Absolute risk reduction is the inverse of attributable risk. Okay, in attributable risk, you are seeing or assessing for risk factors. In absolute risk reduction, yeah, you have the word risk in that, but it's risk reduction, meaning that you're improving. If you're reducing the risk, you're improving. If you're improving, you'll see this smiley face right here. That's why these patients, this group in the treatment group, has a smiley face, because they have less of the outcome than do these on placebo or the control group. That's why absolute risk reduction will actually take into account how much incidence has reduced based on this protective factor, which will be the pills or medications or whichever positive intervention is given for the patients. That's what absolute risk reduction is, and the way you calculate it is a little different from attributable risk. So look at this graph right here. In attributable risk, you expect the exposed group to have a higher incidence than the non-exposed. But since here we're talking about a protective factor, which would be the treatment, the non-exposed or placebo group will have the outcome more often than those which actually are improving or reducing the outcome. That is why you just have to swap the formula, and if you don't swap the formula, it will give you a negative answer. If you use the attributable risk formula, it will just give you the same answer, only that with a negative sign. So understand that what you have to do is that you have to put this time the incidence in the exposed group on the other side, because the incidence in the non-exposed group will be higher, because we're talking about these without the protective factor. Okay, so that's the formula for absolute risk reduction. Now, we have this example right here. We have a group of patients with a treatment, group of patients with no treatment having 75% incidence of heart attack, and this other group with the treatment called Lifesaver having 25% incidence of heart attacks. So what are we talking about here? We're talking about a protective factor that is reducing the outcome, and it would be this column. How do we calculate the absolute risk reduction? By doing the incidence in the not treated, which would be 75% minus 25%, gives you a 50% absolute risk reduction, which is right here. We'll see it. Wow, 50% reduction of heart attacks. That's incredible. But you can also calculate relative risk reduction, which is making the same thing as would be ARR, which would be 75 minus 25% is 50% reduction, and put the denominator or divide that over the incidence in the non-treated group or the control group. That would give you the relative risk reduction, and that would give you a number much higher, would give you 66%. So for example, you would do 75 minus 25% gives you 50%, over 75% or 0.75, that's the way we got to 66%. So be careful when you have studies that give you these huge numbers. It's better to convert it into information that is more understandable for us. That's why the NNT is more intuitive for clinicians to understand, and that's why we're now going to calculate the NNT and the NNH based off these two values we just saw, the AR and the ARR. Okay, what is the number needed to harm? So if we're talking about harm, we're talking about a sad face right here, and we're talking about being exposed has a higher incidence than the non-exposed. Why is this? Because the exposed will actually be exposed to a risk factor. Okay, so the definition for number needed to harm is number of patients you need to expose to induce one additional bad outcome. And NNH of 5 is equal to, exposing 5 new people for one new bad outcome. What is NNT, or number needed to treat? It's the exact inverse of the NNH. So in this case, the number needed to treat is based off the absolute risk reduction, meaning that you have a protective factor, which usually is a positive intervention. So this is the treatment group, and this right here would be the placebo group. And that's why you have the smiley face right here. Okay, so in this example right here, look at the two graphs. The exposed group has 40% incidence of the disease, and the non-exposed 10% incidence of disease. What are we talking about? AR or ARR? Yeah, you know it. We're talking about AR because it says it right here. And number 2 is because we have a higher incidence of the disease in the exposed. So meaning it has a risk factor right there. Okay, next question is, with the AR, the attributable risk, what can you calculate next? The number needed to harm or to treat? Yes, it's the number needed to harm. So now calculate the number needed to harm based on this. We still don't know the formula, so wait a second and we'll get to it. But this is the formula right here. We'll see it in the next slide. So the way we calculate the NNT and the NNH is just using the inverse of the AR or the ARR. So let's try to make sense of this. The NNT to treat is equal to 1 over the absolute risk reduction. So if you think about this, how many new patients do we want to save or reduce the outcome or how many do we want to figure out that have been saved? It's just one. We want to know how many we have to treat in order to reduce the outcome in just one person. That's why we have the number 1 here, and that would be over the ARR. How can we calculate this? We can take this to this side of the equation, so we can say the NNT, number needed to treat, times the absolute risk reduction is equal to 1. We already know the ARR. We are missing the NNT. So, okay, let's now try to figure this out. What is the absolute risk reduction telling us? It is basically telling us how much of this risk of getting the outcome has been reduced by treating the patients or by exposing the patients to this protective factor called treatment. Okay, so that will give you a number. It will give you a fraction or a proportion. This proportion is always a number which will be smaller than 1. So it might give you, for example, 20%. So 20%, which is the same as saying 0.20. So then what you have to figure out is how many times does this number you have as absolute risk reduction fit into 1. So you have to, how many times do you have to multiply the absolute risk reduction? How many times you have to multiply the absolute risk reduction for you to get 1 person who will be saved, or 1 person who will be 1 person less with the outcome we are studying. So in this case, if the absolute risk reduction is 20% or 0.20, here we have 0.20 once, 0.20 twice is 0.40, thrice 0.60, 4 times 0.80, 5 times is 1. So we can say that 5 times 0.20 equals 1. So 5 is the NNT. But this is just so you understand it. Of course, if you already know how to calculate the ARR, you just have to do 1 over 0.20. It will give you the number 5. But this is so you understand why the NNT is the reciprocal of the ARR. Maybe you have to listen to this a couple times and try to think about it so you can get to it, but there you have the explanation. And let's see this other example. So in this example, what are we dealing with? This is one group, this is the exposed group, controlled and exposed group. Are we talking about a protective factor or a risk factor? If blue is the outcome, would it be a protective or a risk factor? Yes, it would be a protective factor because these pills right here have reduced the incidence as compared to the non-exposed group. So next question is calculate the ARR or AR. What would it be? If we're talking about a protective factor, we're talking about absolute risk reduction. And based on that, you can calculate the NNT, number needed to treat. Okay, so try calculating this. You already know how to calculate this. I'm gonna show you the math right here. If you have any questions, tell me. But well, let's try to answer it ourselves. 20 patients here and 20 patients here. So the incidence in the non-exposed group is 4 over 20. That gives you 0.4 over 20, 0.2. And the incidence in the exposed or treated group is 2 over 20, which is 0.1. So the absolute risk reduction would be this 0.20 minus 0.1 will give you 0.1. And the NNT is the reciprocal of 0.1, which would be 1 over 0.1, which will give you 10. You can pause the video, see it through, and there you have the answer. This question right here is a question for you to do on your own. Here you have your 2x2 table. Here you have your formula, and let me know what's your answer in the comment section below. And this is a summary for what we just talked about. So these are fundamental things you should remember. Out of all this, we try to explain how we got here, but in the end, these are the things you need in the exam. Number needed to treat. This is the reciprocal of absolute risk reduction, and number needed to harm is the reciprocal of the attributable risk. And when you're trying to go through papers and start analyzing evidence, remember that if you hear someone promote a treatment by saying it is X% better than placebo, are they talking about relative or absolute risk reduction? That's an important point, because usually relative risk reduction is even larger, an even larger number, but in the end it's the same effect. So don't be fooled. That is why the NNT usually helps us, doctors and clinicians, understand this better, because NNT is more intuitive. You can understand that an NNT, number needed to treat, of 10 is incredible, but an NNT of 500 isn't very good, right? So that's the idea of getting to these different surrogates. And in the next video, we'll finish off seeing all the other calculations we can get off from attributable risk, which are these three we are missing. And that's it. Here's the bibliography. I'll leave this in the YouTube video in the comment section if you want to copy and paste. See you in the next one.